Hello, and welcome to Masters with Masters. I'm Ed Hoffman, the director of NASA's Academy for Program, Project, and Engineering Leadership. These learning events bring together two master practitioners to share their thoughts, their reflections, and their insights into the leadership of complex and challenging programs and projects. It's truly an honor to have with us two guests who can talk about the complexity of leading major programs that are on an international scale. First, I'd like to introduce Dr. Kuniaki Shiraki, who's been the Executive Director of JAXA's Human Space Systems and Utilization Mission Directorates since 2007. In his previous position, he was the International Space Station Program Manager for JAXA. He's been involved in the Space Station program since the preliminary study in 1985. Earlier in his career, he was responsible for the development of several satellites and the H-1 launch vehicle. Shiraki-san, welcome to Masters with Masters.
Thank you very much.
I'd also like to welcome Bill Gerstenmaier, who's the Associate Administrator for Space Operations at NASA, a position that he's held since 2005. Previously, he's held positions in the Space Shuttle and Space Station programs, including Shuttle Mir Program Operations Manager, Space Shuttle Program Integration Manager, and the Program Manager for the International Space Station. Bill, thank you for joining us as well.
Thank you.
One of the places that I'd like to start for our discussion is the nature of international collaboration. Both of you presented at the Project Management Challenge 2011, and in your discussion you talked about and demonstrated the personal connection that you established with each other over time. Shiraki-san, your involvement with the space station has been since JAXA decided to participate in the program. Can you talk about how the collaboration with NASA and the other partners has changed over time for you?
Okay. At the beginning, when I was involved in the station program, I was just before 40s. I'm quite ignorant about NASA at the beginning, except its glorious history in Apollo era. We were newcomers in the program. We tried to introduce ourselves and the keyboard at the beginning of 1985. NASA was not much interested in us then, though. We have been keep asking NASA to integrate the keyboard into the ISS and launch as quickly as possible for a long time. There were struggles and fist fighting on the way for the interface definition and the keyboard applicable document development, or that's the era of 1986 to 1989. At the time, we collaborated with ESA because they have the same issues. I was very acknowledged ESA colleagues to take the lead on these matters to work with NASA or to fight with NASA. Finally, we became good partners, I believe, overcoming the struggles and increased the understanding of each other. And to some extent, the personal characters have strong influence on the way of doing.
Thank you. Maybe we'll come back to the fist-fighting discussions, but I'd like to go to Bill. And you've emphasized many times also the importance of the personal relationship to establish the collaboration and the trust to be able to be successful in such a long-term partnership. Can you talk and tell us a little bit about how do those dynamics get established and how do they improve?
Yeah, I think it's really interesting when Shiraki talks about kind of the beginning of the space station program. You know, we at NASA, when we started, we didn't know much about international partnerships and international relationship kind of things. You know, during the period that he talks about, we were really struggling to get the space station program moving forward on its own. You know, we had a station that used to be fully assembled where the truss segments were actually all built from hand, and then all the components were installed. I call it sticks and balls space station. And then somewhere in there we got redirected to go back to pre-integrated truss. You know, we used to have the Western program office here in Washington. That went away somewhere during that same time frame. So to be fair, NASA was pretty fixated on its own problems and didn't think much about the international partnership aspects. What I've come to know now is if we could have figured out a way to talk about that, the international aspects could have actually been a selling point that could have helped us through that period and helped us with the transitions. But we were not mature enough yet, I don't think, as an agency in understanding how to use international partner relationships and what a partner could bring to the discussions that we were having. We were kind of working our own problems and we're really not spending much time with the partners. But then again, as we've talked, is I think what's happened over time is we've really developed more than a professional relationship. We have a personal relationship where I can share what's really going on with the agency, with my international partners. So then they can see the struggles that we're facing and they can describe to us the struggles that they're facing. So then we can really work together. But until that trust comes about where you really can share those internal agency problems with another agency, that doesn't work so well. So it took a little bit of time until that trust came out between both of us, that we realized that by us really sharing things back and forth, we could actually help each other in a way to move forward. So it takes time, and it doesn't come from teleconferences, and it doesn't come from formal negotiations. It does in a sense, but it really comes from the times when you get to go share a meal or you get to go into town and do some things, and actually the barriers to the formality of your position kind of goes away, and then the understanding of what really drives you as a person to do your job comes out. Then you can start really starting to work together internationally.
Right. So it sounds like one of the key learnings for other leaders of complex projects, programs, is the realization that when you're dealing with something so challenging, complex, potential dangerous to get so focused on your own team and yourself that you don't see the larger team and the importance of building those relationships. You talked about, I guess, food and getting together. Are there other things that each of you attribute to the increased trust and the collaboration of working together, things that you, if you were starting over, again, that you would make sure to emphasize this time?
What Bill told about at the beginning was correct, and I have the same feeling. To develop or implementing the trust each other was the first starting point to start collaboration, which means technically as well as politically, whatever.
What I always find interesting is if you look at the modules on board Space Station, the only module that is its original length is the Japanese Kibo module. If you look at the European module, it used to be about twice as long as it was, and then through budget cuts, it got cut in half. The U.S. laboratory also got cut in half somewhere along the line, but the Japanese were able to stay with that original vision and continue to move through all this turmoil and all this struggle we went through, and they kept their original vision for the lab in place. So I don't know how you build this relationship, but it really comes through strife and face and common problems that these then start to learn to trust each other.
Yeah, actually, when we brought that concept to the Houston at 1985, we brought to the SSCB, and our module was the smallest module compared with the NASA. NASA has 2 labs and 2 hubs, and ESA has the longer modules. And we asked, because our configuration has a unique, that means all functions are in just one module. I mean the robotics arms, logistics module, those kinds of things are unique to our modules. And we are quite asked why that robotics can be used by Canadian arms, why NASA has a logistics module. Do you need that logistics module? So those kind of askings, the need of our elements were our concerns to maintain our configurations. And we have been working very toughly to keep that configuration through the way to the 1993. And at that point, the NASA and the ESA has just redesigned to a small size, and we maintained that as the original configuration. And at that point, we are the largest module remained. But at the point of time, at this point, we are sometimes asked by the government why we didn't restructure the scale small sizing at that point. That is other aspect we asked. But we wanted to maintain our configuration to the extent we have developed the first concept.
And I think what's interesting about that time frame was, again, because we didn't know how to do international partnerships, each country or an agency was kind of pushing for their own concept. Mm-hmm. And they really didn't want to share capabilities back and forth, right? We wanted our module, and the Japanese were going to have their module, the Europeans were going to have theirs. We were together, but we were still separate and all in control of our own pieces.
Right.
Only later, when Columbia occurred, and now that we're retiring the shuttle, do we realize we are actually dependent upon each other, and now we're actually sharing functions and commonality amongst ourselves. So I think as we go forward in future programs, we need to start out with that concept to begin with. It's not separate pieces all integrated into a whole. We need to now look at it as an entire team from the beginning and distribute things and be dependent upon each other from the beginning. And that's a tough thing. I think we can do it now technically, but I'm not sure our governments are ready for that, right? They still want to look at it as, a U.S. space station with international involvement instead of an international space station of which we're maybe the lead. So we got to figure out how we now get our governments to step up to this ability to let go and really cooperate at a new level where you're really interdependent between the various partners.
Yeah, it's interesting because obviously you've had a strong relationship because of the challenges of the mission, the technical challenges, the fiscal challenges, the team challenges, but you have that experience. So in the future, you expect that the working together would be more effective, but now you have other stakeholders that have a lot to say and haven't had those exact same experiences. One of the things I wanted to talk about was learning from failures. And obviously in something that's any kind of a project, but something as complex as space station and the missions that you've been involved with, part of it is from learning from what's taken place before, small and large. Bill, you've been running space operations, mission directorate since the return to flight. And obviously Columbia had a big impact on NASA and your directorate. Can you see certain lessons that came from the Columbia accident that helped make us better today in both the shuttle as well as the station program?
Yeah, when Columbia occurred, we weren't really ready for loss of shuttle. We didn't have a formal contingency plan that said we would lose a shuttle and then have to stand down for an indefinite period of time. And that was a real struggle for us because we needed to keep station moving forward. We were afraid that if we decrewed space station, we might lose the momentum of moving forward and maybe not complete space station. So, and we didn't know when shuttle was going to return to flight. They had a lot of work to do to get things figured out and worked out. We had to drop our crew size to 2. We had to get, pretty inventive with our logistics resupply. But the hardest thing was there was kind of no end. We didn't know when the shuttle would return. So then I had to develop a planning sequence that really just looked ahead a little bit, and we would just protect for a period of time, kind of with uncertainty. So it was more important to know when the decision had to be made than actually what the decision was. So we kind of kept a running timeline that we need to make this next progress flight with food, and we're going to have to protect for this next increment. We worked at, internationally across all the teams to make sure we kept moving forward during this period of time and to keep some research going forward for all the partners, for the Europeans and for the Japanese. So we had to balance in this tremendous uncertainty. And I will tell you, I've used that continuous because it seems like in any program or project I'm in, you've got the nice perfect plan, and then once you start executing, your budget gets cut or this thing gets moved or this module doesn't deliver. So to have that flexibility and the ability to adapt and figure out how to keep moving forward is a tremendous asset. The other thing we did during Columbia was our trusses were completing, and I actually completed the truss, and then I would not let the engineering team go back and modify the truss. So when the truss was completed on the scheduled date, we were done. No matter how much we wanted to improve it, no matter how much testing we wanted, we weren't going to go do it. We actually stopped work on that truss and went on to the next truss. And that allowed us to keep the budget intact. If I would have carried all those trusses in processing and continued to refine and improve all along, we would have eaten up our entire budget and never delivered anything. So I had to hold to a schedule, even though the environment around me gave me the flexibility to actually move the schedule out. I had to stick back to that plan. So I think the things I learned were how to manage in true uncertainty, where you have no idea of when the end date's going to be, and then also how to maintain portions of your schedule and keep things moving forward, even though there's no physical driver to make you hold those schedules.
I'd like to maybe come back to talk also about how do you get a team to be able to deal in that kind of world of uncertainty, because you obviously have to build an adaptability and a trust in a larger vision, because constant changes for some people would probably make them crazy or make them want to go in a different direction. Maybe before that, Shiraki-san, JAXA, like NASA, has had major successes, but also has had failures. How does your agency learn from things that didn't go as well as you wanted, and how do you incorporate that into how you have successful programs and projects as you move forward?
Actually, when the talk about the JAXA or before the NASA space program, we started from the introduction of the U.S. launch vehicles. I mean, starting with N1 launch vehicle that was introduced from the U.S. SWA Delta. And the next N2 launch vehicle is for Delta 2914 or something. And they were all successful. And they gradually introduced the domestic technologies for our Japanese launch vehicles for H1. And the H1 project was successful. And the fourth launch vehicle which started was H2. That is the first purely built by Japanese technologies. However, it failed 2 times out of 7 flights. So that was quite challenging for JAXA at that point of time, because of the period of introduced technology. The launch vehicles were okay, were very successful, but once we go into our own technology development, we have the 2 successful failures. And also at the time of the H2 project were ongoing, they also introduced the H2 launch vehicle, H2A launch vehicles to improve the cost and simplify the system. As that is JAXA's challenge, to cost down and more reliability enhancement. The switch to H2A continued to the success up to 5th flight, but failed at 6th flight. The problem was the advanced solid rocket motor with nozzle failure, which has not occurred before by the time of 5th flight. So they investigated and reviewed the whole systems and developed the new nozzles that can work in higher chamber pressure. So for that activities, they organized a problem resolution team for that issue resolution. And also they introduced the systems engineering process to work with for the issue resolution. And those kind of extensive activities which JAXA took for the working and resolving the H2A launch vehicle issues worked well. And after we continuing the success up to 18th H2A launch vehicle. So I believe that our approach to work for that issue resolution or problem resolution worked well.
So these challenges, these failures actually help us get better. You both talked about different things, the importance of looking at it at reviews, the implementation of a systems engineering approach, having a clear vision so people can focus, the ability to keep going towards the plan. How do you get a team? Because you're working with so many people within your agencies, but then with your partners. Is there a way that you as a leader try to get your folks to understand that we will need to adapt and fundamentally once you lay out a plan on paper, there's going to be something that's going to change? Is there a way to do that, or is that just something you learn as time goes by?
Well, there's lots of pieces. I would say as I think back again on Columbia, when it occurred, whereas before we didn't think much about the international aspects, we actually moved modules up earlier so we could launch the Kibo module a little bit earlier, launch the European module earlier in the sequence. So we had to change the fundamental assembly sequence to try to advance their modules. So whereas early in the program, I think it was pretty much NASA trying to figure out our own problems, by at least that point in the program, we understood that it was bigger than just the NASA agency. We had to go look at what problems the partners were facing because they were having trouble with their own governments, because while we're trying to get the shuttle back flying again, their modules are sitting on the ground. They had promised that they were going to fly their laboratories early. They were going to get good returns on investment. It wasn't coming. We recognized their concerns, so then we had to go adopt and change our program to try to meet their concerns. So we actually had to give up some of the things we wanted to do on the U.S. side to help them out. So I think in terms of team communications, you recognize that these tough situations, when they come, you have to potentially give up some of your own control to your other partners or the other team members to let them go succeed. And so you have to be able to discuss what is, from the overall organization, what is the most pressing need for the overall organization? How do we keep Space Station as an entity moving forward? It does no good if the U.S. segment progresses, or in a systems engineering standpoint, if your component is ready to go fly but nobody else's is, that doesn't work. I may have to pull funding out of you even though you're ahead of schedule and give funding to somebody else to let them get caught up so we can achieve the overall goal. So I think you've got to really be open with that discussion and understand the needs of the overall team to keep the whole project moving in one direction.
Yes. Just before Columbia accident, the ISS program looked like going smoothly. I mean, NASA is looking for the early launch of Node 2, which is our international modules to be attached. So we are asking to bring up Node 2 first as quickly. And just before Columbia, it looks okay, but very close to that launch. But just before the Columbia accident in 2003, January, February timeframe, we are almost finished our Kibo module integration at Japan at the Tsukuba site. And we are preparing for shipping to the KSC in 2003 May timeframe. And at the accident of the Columbia, I think whether we should ship or wait for a moment. And someone said we should bring the keyboard to the KSC as soon as possible to conduct the integrated testing with Node 2, mate or something that they named testing. That was scheduled at the point of time, the October, November timeframe then. But I have some hesitation whether to ship because we are not quite sure when the shuttle will return to flight. And I was informed that the shuttle has grounded. So I wondered how long it has to wait. But there are some requests from NASA to ship as soon as possible to show our intention to proceed the program. So I decided to ship our pressurized module to the KSC in May or June timeframe. And though it took about 5 years to be launched, but I think it was a good decision at the point of time.
And I remember making that decision, and we struggled, right, because we could have just left the module in Japan, but I didn't want to put pressure on the shuttle team, but I also wanted to show that Space Station was moving forward. It allowed us to do some unique testing that we wouldn't normally get to do, because since the node was still on the ground and Kibo was available, we could actually do some more detailed testing. So that seemed advantageous. But it also seemed good to show movement in the station program, that station was still moving forward even though Columbia was going on. And I thought it would be beneficial to both Japan and to NASA that we made this move early. So I remember having lots of discussions with the Japanese about whether we ought to put it in a container ship and move it over, or we ought to wait. And I thought we made as good a discussion or good a decision as we could, and then time would tell whether that was a good decision or not. But that was clearly something we did not need to do during that time frame. But we thought collectively, and I think we made a good collective decision, even in hindsight, to go ahead and move forward with the module movement to KSC.
Yeah, the importance of making progress on your mission so you don't lose the energy. You've both mentioned several times the importance of getting the total team to understand the importance of optimizing at the system level and not to just focus at the subsystem in terms of whether it's agencies or organizations.
Right.
One of the things that's also clear, both of you are obviously outstanding leaders, and so you demonstrate your openness and communication, respect for each other. So that probably should also be said. One of the great challenges, obviously, of any kind of aerospace mission is that you're working with many different agencies and organizations, from industry, universities, and obviously governments. If I could start with Shiraki-san, what is one of the things that we as NASA can learn about ourselves? What are some of the key challenges in terms of working with NASA? And what are some of the things that we can do better in terms of how we operate?
What I have learned through the international program is, I think that I have to learn the difference between the agencies, between the countries first. I mean, when we are involved in the program, we are trying to the way we are doing in Japan, but there are different way of doing in NASA. And first thing we have to do is to learn the difference. What is the difference way what we are doing? Also, we have to learn the background of the way of doing their activities and culture, and politics, and way of thinking, difference in process or organization. So I think I have learned a lot about how the U.S. or Americans or NASA people does for the making the decision or proceeding the process or program. So the first things I have to learn was to learn the difference. And without those understanding, we're always facing the frustrations at the front. At the working level. There are some struggles, a difference of opinions, or difference of the difficulty of understandings. Specifically, sometimes it's very difficult why the NASA is insisting on some specific items. But there are a lot of many backgrounds and way of their thinking. So to understand each other, it is very important to understand their background and cultures. And to visiting the other countries is one of the ways to learn what they are doing there. So that's what I've learned through this program.
And Bill, I'll ask you the same about JAXA and learning about Japan and this mission.
Yeah, I've learned a tremendous amount from working from all the international partners. The thing that I kind of enjoy now is that I have a pretty good relationship with Mr. Shiraki, so I don't need to be quite as culturally aware as I might need to be. I can be a little more American, right, and be a little more upfront sometimes, and I know he'll understand, or at least if he doesn't understand, he'll correct me gently that you're being kind of American, or you've got that NASA attitude, right, and then I'll reflect back and I'll think, yeah, okay, that's right, I gotta change a little bit. But I think the neat thing is I can be a little more relaxed now. Whereas at the very beginning, when I was running the space station control boards, it was much more formal. I was very careful. It was very difficult with the international boards because the cultures are so different between the countries. I remember when we were trying to set the assembly sequence for space station technically, and I was having just an unbelievably confrontational argument with the Russians about what the launch order ought to be and the sequences. And that's pretty typical in their culture, right? It's more upfront, in your face, kind of arguing back and forth. Not that it's not seen as an argument, it's not personal, but it is negotiation at its top level, right? So I am really engaged. And then I and it wasn't Mr. Shiraki, it was a previous program manager from JAXA, and MEXT was there. And I turned to them, and I stayed in my Russian negotiating mode, and I was drilling them. And then all of a sudden, I saw my JAXA partner just kind of like melt into his seat, like I go, oh, sorry, just a minute. So then I had to go back and switch my tone, my mannerisms back to a more civilized, more congenial kind of manner, and get out of that screaming at you, throwing things at you mode. So it was really hard for me as a leader of this multilateral organization to actually adapt my management and leadership style to the individual to which I was addressing, and that was very difficult. And you couldn't have a very good multilateral discussion because it was so difficult. But now we've worked together so much, we can understand each other's differences. You know, Shiraki understands Mr. Krasnov, and he understands us. So then we can be kind of we've almost created our own culture within the ISS program that's a blend of all the nationalistic cultures into one now, where we can all communicate back and forth, and we can actually go into a meeting without kind of a scripted, formal, you say this, I say that, and we agree. We can actually have a real discussion. So we've actually bridged that gap where we've kind of created our own quasi-new culture called the ISS culture. But it only came after multiple years and multiple challenges of working together.
Yeah, exactly.
Fascinating. Yeah, obviously it sounds like you have your own world. Well, I guess in a sense you do. Let's see. Are there any questions?
Thanks. I guess it just seems to me the obvious question as we're retiring the shuttle and moving towards the future of exploring beyond LEO, how you think we can capitalize and build on all these relationships you've made in the ISS culture.
Well, we're starting to talk now as to how we can bring the partnership together and use space station to help bridge into the new world. I ask all the ISS partners to develop a lessons learned document from ISS, and the document was geared towards what lesson do you think we have learned in ISS that most applies towards exploration, and we compiled a pretty nice document to do that. We consolidated the upfront section into the way we kind of integrated all the answers together, but then I thought there was a certain beauty of leaving the raw inputs from each one of the partners in the back. So what's kind of neat is you can see the culmination of all the integrated responses to that question, what's the most important lesson for exploration up in the front, but then in the back you can actually see the Japanese input, the Russian input, the European input in the back in its raw form. So then you get a chance to see how that culture kind of blends forward. So that's one thing that we're starting to do now, is we're starting to figure out how we can use ISS to be that next piece of exploration. But it's again hard because we've got to work with our own governments as well as our own agencies, and that becomes problematic to us.
Yeah, exactly. Because the experience we have done in the past through the ISS program was quite very valuable, and we better to keep us on lessons learned and to bring the future programs. And there are a lot of things we have learned through the program, including the technical as well as the political, and those kind of lessons learned are very valuable for us in the future.
Absolutely. Yeah, another question.
My name is Norimitsu. I work in Washington, D.C. I remember the huge document work just after the redesign of Freedom Program. So do you think about the lessons learned to avoid such too much document work for the future programs?
Who's asking you? Me or?
Both of you.
I think one of the things I have learned is there are a lot of documents in the way of NASA program operates. And originally, our JAXA or NASA has not produced so many documentations in the implementation of the project or program. But once we have worked with NASA, we are asked or obliged to produce a lot of documentations. But I think for for such a complex program, I understand and recognize those kind of documentations are needed. Some documents become disappear, but there are essential documents which are needed to make avoid the misunderstandings between the elements or partners. And also he pointed out that the redesign activity, what was happened 1993, with Bill Clinton became president, and he asked NASA to redesign the activities. And now we have experienced tough joint activity at Crystal City starting the 93 March to June timeframe, I think. And they've created a lot of documents. And I am not quite sure the way of what they're doing for changing the program or changing the way what they have done before to innovate the new or create the new program, a new way of doing. That may be necessary specifically in case of NASA. So usually we JAXA will not make such a document, and we don't do so many activities such as they did in the redesign.
Yeah, I don't know. I struggle because part of the benefit of building the documents is it forces a dialogue in a lot of detail that needs to come out. So there's an advantage of doing that. And then since you've been through all those discussions, it sometimes is advantage to you to write it down, because then you've got to now transmit that to everybody else and they've got to go follow it. I think there's probably a little bit too much documentation, but I think you can also go to the other extreme where there's not enough, that you don't have a document, because it also has to go external to the agency. You know, we have to go to sometimes the State Department, or we have to go to other government agencies and show them what we're doing and what progress we're making. And if we have a signed document, there's certain advantages to us to say that, hey, we've got agreement down to this level and these are our commitments. So I don't know the right answer. I would say I think we spend a lot of time and there's an awful lot of documentation. We need to go think about that and figure out a way to maybe make that a little bit smaller. But I think it's probably in the big international programs that there may be a little more documentation than you can get by with in smaller projects.
Maybe at the core also of the question is the lessons that we learn. This is probably the grandest of programs that humans have ever been involved with. It's obviously gone over many, many, many years. How do you think we should look at capturing the lessons of these are things to really learn, these are things not to do? Have you thought about that? Or are there things that JAXA, NASA, is doing from that learning of lessons standpoint?
Well, we wrote the document, geared towards exploration, but also the other thing is that the other amazing thing is all these modules are actually been built in their own countries, and they all plug together, and they've actually all worked, which is sometimes amazing. So then what I think out of that is the interface control documents and the details that specify things back and forth, and the testing we did even through computer sims, the kind of things, all proved to work, right? So it may have been a little bit on the too much standpoint, but where we didn't want to have a failure or a huge interruption in the sequence, we kind of went above and beyond to make sure all those interfaces are there. So I think, again, thinking back on this, we may be a little bit on the too much side, but we need to be careful we don't get too small. We clearly need to think about how we capture the lessons learned from this program. I'm also a big believer in springboarding off of this program. So I would like to use, we have the ISIG, which is a larger group of countries that are starting to plan the exploration activities. I'd like to figure out a way that the ISS team can kind of plug into that activity. And in fact, they're doing a global exploration roadmap. And we're going to the ISS team have made some inputs into that global exploration roadmap. So we're seen as a kind of a participant in that. So that's a way that I hope that we can transfer the lessons in a real sense to the next program by actually us participating in the beginning steps of that next program. So rather than document it and put it in a book, if we can actually contribute and help directly in that activity, I think that might be a more effective way of transitioning what we've learned over the multiple decades into the next program.
Yeah, the springboarding, which I guess massive scale prototyping of how you've learned different things and be able to use it in continuity in terms of work?
Actually, when the program started, they start with the documentation trees, and that identifies all possible documentations. So at the beginning, there are a lot of documents. They start for drafting. But on the way, we proceed the program, the documentation which were essential can alive or can be used for a long time, but unnecessary document has almost disappears. So in that sense, as the program move on, the screening of the documentations were happened. So I think that currently living documents are important and essential to proceed the program.
And I think that's a really good thing. We could go back and look and see which documents we're no longer actively using, right? And then in hindsight, then say, okay, this is a more skinny down documentation tree to start out with. So we haven't done that formally, but we should go back and look and see which documents are really active that we're actually using and which ones we are not using. We haven't done that yet, but we may get an action out of this to go back and go think about that.
I hope an action doesn't come out of it.
No, it will.
It will.
So, yeah. So we learn both ways. So this is a good thing.
If people think there are actions that come out of these forums, then people will probably want to do them again.
Yeah, that's all right.
No.
They're not actions. These are learning.
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 That's right. Yeah. Other questions?
You both mentioned in terms of international partnership that you also have domestic interests, your own governments, your own politicians, your own industry. When you deal with those stakeholders for your program, what is the value or the views about international partnership, international cooperation?
I don't know in the U.S. that we fully appreciate the benefit we get from an international program, right? We see the overhead and we see the complexity, but I don't know that we see the real benefit of an international program. Now, I think ISS can show you that. You know, I think ISS wouldn't be where it was today without international involvement. You know, even when Augustine looked at the program and the partnerships coming in, you know, the JAXA representatives and ESA representatives coming in to talk to Augustine about the value of the ISS program, that was tremendously beneficial. You know, I could have said that this is a wonderful program until I was blue in the face and it would have never done any good. But somebody from the outside that is not from this country that comes in and says this program has real advantage to us, we need the U.S. to continue. That's a pretty strong message. So there's a real strength to this international partnership that you get more credibility in your own, not in your own country, but in the opposite country. Same when I go to Japan, I'll meet with MEX ministers and other folks, and I think, you know, my opinions and my positions, even though they're 100% in agreement with JAXA, carry more weight just because I'm coming from a different country to go talk to them. So there's real advantages back and forth. But then also the problem is that then the country or the government has to realize that when you're dependent upon somebody else, you are dependent upon them and you have given up some control. And governments don't like to do that. They want to be 100% in control. They want to know everything is controllable directly by them. But to do these big global partnerships, you're definitely letting go, and that's problematic. And I think we need to do a better job of conveying to our governments the advantage of the international partnership. They see it sometimes as a foreign policy tool, but they don't see what we're able to gain from a technology standpoint to move forward.
Oh, actually, Japan decided to join the ISS program to develop ourselves or to implement our Japanese program for human related activities. I mean, for Japan, it is difficult to implement a human program with just own unique way in a sense of the monies and technologies. So involvement in the ISS program was one of our desire to implement or to take part in the human space programs. So once we have decided we wanted to be a part of the station program and we wanted to take some responsible part of the program as we proceed the program. So we have been trying to maintain our configuration to the extent possible, because our configuration shows our Japanese national intent to be a part of the program. I mean, the configuration is not just a technical configuration, but that shows our Japanese national intent to be a part of that program. So we have been working together to be integrated to the program or to the ISS. And sometimes we have been, our Japanese delegation went to the U.S. Congressman or someone to appeal keeping the program when the U.S. is in some tough situations to maintaining a program. So in that sense, we are very pleased to help the U.S. in that time. And anyway, the other point we are telling our government is international program is very good in the sense of communicating and learning the difference of the countries and learning the human space technologies through our integration in the program.
And there's another problem too, is export control, right? We're not allowed to technically interchange a lot of technical details on how we go do things, which becomes problematic when you have to work this close together, right? I mean, so that's been there's a natural, we want to share more, but then we're prohibited from sharing because of export control. So then that makes it a very interesting situation back and forth. But then there's some advantages of that also. I think it's nice in the sense that they're independent programs. When I look at the science that's being done on the Kibo module, they have the unique exposed facility and the airlock and the little fine arm to go take items out of their airlock, and they can position them outside on the outside. That's the only module that can be done in. And so there's a beauty in the fact that they didn't conform to doing it exactly the same way that we're doing it, and they're actually pursuing kind of a separate science activity stream than we are. So there's a strength in the fact that there's individuality and there's uniqueness, but then we've then got it conflicted. If we stay totally unique and totally isolated, then you don't get the benefit of being a partnership and being dependent upon each other. So there's some right mix between those two, and that's a constant struggle, and the governments interact and interface with us when they put export control restrictions on us, or we get legislation about we can't do this or that. That becomes problematic to us. So there's a natural push and pull, and that's an overhead of an international program that doesn't exist in a domestic program where you can control things yourself.
Yes,
challenges.
There are the constraint of technical transfer for both sides, and we worked just through the interfaces or some requirement basis, and that we have the common requirement for design and development, and also we have the interface defined for design aspect, and those two approaches, I think they worked well, and the current station, our keyboard assembly, which was flown on 3 space shuttle, and it was unbelievable for me. It was a 3 keyboard flight on space shuttle became a complete assembly without any problems or anomalies. So we worked through the interfaces and the requirement basis.
Many challenges.
Yeah.
Let's talk maybe as we start to come to towards the end of our discussion, the future. So there's been a lot of construction. International Space Station is there. What are you excited about as we begin a decade of being able to utilize the space station, or the things that you see as particularly compelling or exciting about where we are now?
I think, again, this is really the period of time for research on board Space Station, and so we need to really push our research agendas as much as we can. We need to be aware of what each one of us is doing, but then I think it's also, as I discussed earlier, the strength is we can cover a whole variety of different research activities. So we're going to continue to do some international events where we get together and talk about research on ISS, and it's not just U.S. research or NASA research. We'll talk about JAXA research, Russian research, and European research. So we're going to get some meetings together where we can talk about kind of the whole research spectrum that ISS is able to accomplish as a whole, And hopefully we can, through those forums, folks can realize that by working internationally, we're actually getting a much broader spectrum of research than if we would have just had a dedicated U.S. laboratory operating in isolation without the other modules being around. So I think the exciting thing is, we've got to take all the energy we put into assembly now and take that energy now and focus it into research and start showing a return on investment to our governments and try to find a commercial activity or a real benefit of space. And there's a whole bunch of physical processes that have the gravity constant in their equations, fluid mechanics and biological things and other stuff. And when you remove that gravity in space, you get a chance to look at those physical processes in a very different way. So we're learning a lot about how bacteria behave and how viruses behave, how the human immune system behaves, how bone loss occurs in astronauts, and then it goes away when they come back. But can we use that period of microgravity to now get new innovative ways to treat bone loss in our elderly? Elderly also have immune system degradation, much like our astronauts. Can we use that again as a function to help the elderly here on the Earth with new techniques to help with immune function degradation? The elderly have trouble with stability, and the same thing with astronauts. They have trouble when they immediately return with stability and neurovestibular activities in the neurosenses that keep track of keeping you stable. So can we learn some techniques from this short-term experience in space and apply that back to our people? So when I look at that, I think there's a really unique window here over the next 9 years for us to really push research in a new direction.
Yes.
Shiraki-san?
Once the keyboard is on orbit, we asked and pressed to fully utilize our keyboard. And that's quite challenging. The keyboard has two capabilities to conduct a pressurized experiment, which use microgravity environment with the support of crew. And also we have exposed facilities that can conduct the observations for the terrestrial and Earth observations. So using those capabilities, we have to make the product from the utilization of the keyboard to appeal the people's national people, publics, whatever. In that sense, that is one approach we JAXA are obliged to. The other aspect is that the ISS is international endeavor. So ESA, NASA, or JAXA, or Russia has their own facilities for experiment. But each partner will work to utilize to best effort for their own facilities. But other than that, because of the international future of that ISS, we are also obliged to use the ISS for utilization field for international collaboration. So we need to look, we are trying to looking for any specific topics which will contribute to the international people, including the world people, to enhance or to improve their lives, or whatever improve our future benefit of the good life in the ground. So those are areas we are looking for to make the utilization more international wide and to appeal the worldwide people for that utilization.
Right. So use the benefits of the different nations to bring real benefits to people. I see we have a couple of minutes left. It's gone very fast. I'd like to ask, one of the things you're both obviously recognized as outstanding leaders by the people you work with and by others. Any tips, or how did you become outstanding as leaders? Are there others who you learned from, that you looked up to, that you pulled some of the skills? Are there certain competencies that you tried to demonstrate as a leader? How did you become to be so respected and effective in terms of what you do?
Okay.
Humility. There's the answer.
I wonder I am so successful or not. But anyway, my background in space started with structural testing of satellite and launch vehicle. I was quite interested in those areas to pursue as professionals first. Those activities included not only the testing, but also we are obliged to fixing and designing the test facilities. So in the sense of the space engineer, those jobs are not so interesting because compared with sophisticated flight vehicles design and development. However, I got quite confident through these activities because the result of any effort will become evident quickly. So in that sense, to conduct or to take that kind of jobs that will come out with the result quickly is very beneficial for the engineers, specifically for young engineers. The case of space station program, it is more than 20 years. So young engineers just can watch very short period of the activities. So they don't know how he contributed to the program or that project development. So in that sense, I encourage the young people to do just short period program first. The second one was I also I felt before 30s because I was just graduated undergraduate institute. So I felt some lack of my knowledge in technical or theoretical background in implementing the program project. And fortunately, my agency has given an opportunity to learn for the master's degree at the university in the United States for 1 year study. And it was quite good opportunity for me. I could get the master's degree at Caltech for studying their applied mechanics. And that enhanced my capability to a great extent. And that was quite a great step up for me. So I also encourage the young people in Japan to study abroad for one moment because the U.S. systems of graduate school is very excellent, I understand. So those are two things that I wanted to just give the message to the young people.
Thank you. Bill?
It's curious that our backgrounds are similar in a sense. You know, I started in the wind tunnels doing aerodynamic research, early shuttle stuff, and supersonic inlet stuff. And I really had tremendous joy of doing that hands-on engineering where you would be in the tunnel getting data that night, and the next day you could actually modify the hardware yourself. It was a pretty low-key program in a sense. But that immediate feedback and getting to see engineering results was very formative at the beginning. And then, you know, I never really kind of planned my career. I just kind of just did things I enjoyed and kept doing engineering things. So I think continual learning is really important to being open and learning. You know, the first time I did anything internationally, I had not been out of the U.S., and I was given a 4-page document or 4-inch thick document of contract negotiations to go do with the Russians, and I had never left the continental U.S., so I think back on that and I thought, what a disaster this is. But somehow I made it through all that. But I think, again, it's the resilience and learning and just having that sound understanding underneath that helps you be grounded. So that, you know, you can be a dynamic, forceful kind of leader, but you can also be maybe more of a quiet with a really deep, solid background. You know, I was very lucky that you know, I had got to do the Russia activity before I got into space station a little bit later. I did early space station design from the U.S. standpoint, didn't do it internationally. So I had a very strong understanding of the basic pieces of stations. So then when I came to be ISS program manager, if you looked at all the things in my background, they all fit really well with the job. And it wasn't I was trying to put those in my background. They just kind of showed up there, and then somehow somebody stuck me in the job, and we got to go do it. But right. So I think that the message there is to always be learning, always want to go back, keep current, be open, and learn from partners, learn from the people you work with, learn with the teams from the teams you work with, and really listen to the discussions. Most folks are really trying to help you in your position. They're trying to tell you something that's important. Really listen to their perspective, understand what's going on, then try to translate back to them why you're going to take a different tack if you have to take a different tack. So then that builds a stronger understanding and a stronger basis for your team as you move forward.
Very good. Well, I'm going to listen to my crew who's telling me we just ran out of time. We're really thrilled to have both of you. You're both outstanding leaders And we appreciate you taking your time to share some of your thoughts and reflections over one of the great achievements and something that's really just starting. So thank you, Shiraki-san and Bill Gerstenmaier. I want to also thank JAXA for supporting the event, and certainly want to thank NASA TV for doing a great job and also getting us up and started early. And thank you all, and as you said, keep learning. So thank you.
Thank you.
Thank you.